Have you ever stopped to think about how some simple, everyday object can turn into a massive cybersecurity headache? That's what we're going to talk about today. We're going to see how something as basic as a boom barrier, when you hook it up to the cloud, suddenly becomes this whole new world of risk. So let's dive in and see how it all unfolds. So this whole story, it literally starts with a popsicle stick, like a hobby project. Just a single popsicle stick, a tiny little motor, and a simple circuit board. I mean, it is about as low-tech as you can possibly get. But somehow, that super simple setup, well, it ends up as a system with a global attack surface, one that's vulnerable to hackers from pretty much anywhere in the world. So how in the world does that happen? That's the journey we're about to go on. All right, let's rewind and go right back to the beginning. We're starting with a classic piece of what the industry calls operational technology, or OT for short. And this idea of OT is really, really important. We're talking about tech that directly touches the physical world. So think factory robots, power grid controls, or, our little boom barrier. This is technology that has real-world physical consequences if something goes wrong. And here it is, our system in its most basic form, a popsicle stick on a motor, an Arduino board for the brains, and a physical touch sensor to make it go. Now the crucial part here is that it's completely offline, totally isolated. If you wanted to attack this thing, you'd have to physically be there touching it. The attack surface, it's tiny, it's local, it's contained. But things almost never stay that simple, right? We're always looking for more efficiency, more convenience, so we start connecting things. And here's the catch. Every single new connection you add, well, that's another potential door for an attacker to walk through. And this timeline just lays it all out perfectly. Look at this. Back in '92, we've got a physical button. That's it. Then, a few years later, we connect a guard's PC. Okay, now the PC is a vulnerability. Then, we hook it up to the corporate network to get some logs. Bam, the entire network is part of the attack surface. And finally, we get to today. We add a cloud service so truckers can use their phones. And just like that, the attack surface isn't local anymore, it's the entire planet. So, why is this so difficult to get right? Well, the real problem is that you have a collision. It's a clash of two fundamentally different cultures, two completely different ways of thinking about how technology should work. See, on one hand, you've got the OT world. Think of it like a fortress. It's built to be stable, unchanging. Change is seen as a risk, so it's slow, it's carefully planned, because the number one goal is keeping things running and keeping people safe. But on the other hand, you have the cloud world, which is more like a river. It's all about flow and constant change. Continuous updates, new features every week. The goal is speed and agility. And when you try to connect the fortress to the river, well, you're going to get some serious friction. And this quote just hits the nail on the head. It's the perfect way to think about the solution. The OT folks can't possibly know every little detail about a cloud service that's changing every day. And the cloud developers, they can't understand every physical constraint of the OT system. So the answer isn't about knowing everything. It's about figuring out what you need to know by asking the right questions to bridge that gap. So, okay, let's get practical. Let's look at a framework that's built around three really important questions that the people who own these physical assets should be asking their cloud providers. The first question gets right to the heart of what makes the OT world so nervous, right? They're used to having these super strict procedures for managing any kind of change. So how are they supposed to stay in control when their system is plugged into something that might be changing every single day without them even knowing about it? The answer, in one word, is transparency. Look, it's not about stopping change. It's about making that change visible. The cloud vendor has to provide a live, dynamic dashboard of what's running right now, not some static PDF from 6 months ago. The OT owner needs to have a switch to say, yes, I want that new feature, or no, keep it turned off. And both sides have to be looking at the same data, so if something goes wrong, they can solve it together. All right, question number 2 is all about trust. The OT world has these really specific security levels for all their physical gear. So how can they possibly be sure that this big black box of the cloud meets those same standards, especially when new tech, like 5G gateways, can just bypass all their traditional defenses? So the key here is for vendors to build trust by showing, not just telling. They need to share live data from automated security tools, things like a Cloud Security Posture Manager, or CSPM, which is always scanning for mistakes and vulnerabilities. Now that data can be super complex, but this is a great spot for AI to step in. AI can translate all that technical security jargon into a clear picture that shows the OT team exactly how the cloud's security lines up with their specific needs. And that brings us to the final question, which is all about looking ahead. The old security models, the fortress model, it doesn't really work anymore. So what's the plan? How do we build a new, holistic security architecture that actually works for this new hybrid world? This is all about creating what you might call a living security model. It means we have to accept new kinds of risks that the OT team can't even see, like an attacker getting into one cloud service and then moving sideways, laterally, to another. It means that any change in the cloud that creates a new risk has to get an explicit yes from the OT owner. And the best tool for this is threat modeling, basically creating a shared map of the whole system, both on-premise and in the cloud, that gets updated every single time something changes. So after all that, where do we land? Well, it all points to a new way of thinking about security, one that isn't based on building walls, but on smart, collaborative management. The path forward is really a simple three-step process. First, you build trust. Get the OT owners, the cloud vendors, and all the developers talking to each other openly. Second, you demand transparency. Insist on seeing that live dynamic data. And third, you collaborate on security. You use all the powerful tools available in the cloud to protect the whole system, both the new shiny stuff and the old reliable gear. And really, this is the main takeaway. Connecting our physical world to the cloud offers huge benefits. So the answer isn't to be afraid of it and build bigger walls. The answer is to manage it intelligently, with clear communication and a real sense of shared responsibility. So yeah, our little boom barrier went from being a popsicle stick to a global security risk. But let's be honest, it's just one example. It's a stand-in for these smart thermostats, the connected cars, and the industrial sensors that are all around us every single day. So the question I want to leave you with is this. What is the true hidden attack surface of your connected world?